This is the second video of three, and I want to talk about jumping. In particular, I'm thinking about a vertical jump that, a la what they do at combines for basketball and football. So the vertical leap test. So as an example, we have Deanna Nolan of the WNBA, who and her statistics are here. So in particular, she has a vertical leap of almost a meter, a little bit shy of a meter. Um, and so you did this first part. What we want to figure out is we want to figure out the forces acting on her feet as she's jumping. But so the first part you did, we got to do it in three parts. The first part you did last week, which is to figure out the launch speed. Okay, how fast is she moving when she comes off the ground? So you can go back and use the kinematic equations to do that. I recommend that you pause the video again. You've got a worksheet which asks you all these questions, though I think it's set up for talking about my vertical leap, which is not as impressive as 85 centimeters. But use Deanna's numbers here. So I'm going to pause to give you time to pause the video, and then I'll come back. Okay, so you should have used this kinematic equation. This is one of the ones I don't like, but it's there, and you use it. So 2 times the acceleration, and this is, so we're considering in this case the acceleration. I want to know her speed as she comes off the ground. So what's her final speed after she sprung up and her feet have left the ground? And so to reach 85 centimeters or 0.85 meters, under an acceleration of 9.8 meters per second squared, she would have an initial speed. Her final speed when she's at the top of her jump is 0. Her initial speed is the speed that we're looking for. We do out all this, and we get a little bit over 4 meters per second. Okay, great. The next thing I want you to do, and I've done it out already here, but you should work it out for yourself. Oh, I didn't give you... Right, so given all of that, we know what her speed is. And now, what I didn't give you here is I didn't give you that we're going to assume, so now she's preparing for the jump. And there'll be a video that you'll look at in class in discussion tomorrow, or you have a link to in discussion tomorrow. But she's preparing for the jump. So she squats down. And let's assume that she springs up to about, so if she's 1.8 meters tall, let's assume that she squats down about a third of her height. So I don't have a good number on that, but it's somewhere between a third and a half. A half seems too much. A third might be a little bit little, but let's assume that. So that's 0.6 meters. So now her initial velocity is 0. Squats down, getting ready to spring up. Her final velocity is the velocity that she leaves the ground with in the previous problem. So that's a little over 4 meters per second. And her distance that she travels is 0.6 meters. Squatting down and jumping back up. So when we work that all through, we get an acceleration of about 13.9 meters per second squared. So 2 things to think about. One, what would you compare that to? Is that a big number or is that a small number? 2, how can we figure out the force that is being exerted on her by the floor on her feet as she's doing this vertical jump? So, hint, you're going to have to draw a free body diagram. So go back and draw a free body diagram for Deanna's vertical jump and pause the video, draw the free body diagram, start the video in a minute. Okay, so remarkably, the forces on your free body diagram look exactly like the forces that were acting on the object if they were standing. So the free body diagram looks almost the same. I've copied the free body diagram from the previous chart. I didn't adjust the length of the arrows, and maybe I should have, because now you might expect these some of these arrows to have changed distance. But the forces are going to be exactly the same. When you sum Newton's law, when you use Newton's second law and sum the forces, they're going to be exactly the same too. It's going to look exactly the same as before, except now you can't set A to 0. So F1 plus F2 minus mg is going to be equal to the net force, which is generating the acceleration. We assume that each foot experiences the same force, so we just take F1 and F2 and make them F. So 2 times F is equal, the minus mg is equal to ma. So I can rearrange that so that 2 times F, the force on each foot, is just m times the sum of A and G. So you should be able to figure out what this number is and compare it to her weight. But you could also, by inspection, just look at what that number is and think about that you're multiplying m times the sum of these two accelerations. And is it bigger than, smaller than, or equal to her weight when she's accelerating as she's starting to jump off the ground? All right, that's going to end video 2. And so check back in for video 3.